Hi everybody. So I'm going to get started here. So today I'm going to talk about the way we actually help the Australian government with their cloud platform. It's come from a company called Vault Systems, and today I'm going to show you just a high-level view of some of this technology and some of the ways that we've helped transition some of the government into cloud technologies. So just want to start off with an overview. So imagine if government services were modern, unified, intuitive, secure, and reliable as some of the everyday web services you use. Today we'll share with you how we leverage automation, new network technologies, and our purpose-built cloud to enable government and innovation. My name is Roland Cabana. I am the CXO of Vault Systems. I'm also the DevOps team lead. Just a bit of background about Vault Systems. We've been around about eight years. We have a purpose-built cloud for government, for the Australian government. We operate 4 independent regions with 2 classifications, one in the unclassified DLM range and the protected. We provide a high-performance, low-latency cloud offering, which enables government to do a lot of legacy movement into the cloud. The challenge we face is around cloud adoption. The Australian government has actually put forward a policy to use cloud first. Now the rationale behind this is to reduce cost, improve efficiency, and modernize a lot of the services they provide to the Australian people. We actually deliver a true hybrid cloud, and I'll get into that later on with leveraging some of the technologies from Mellanox and Cumulus. We migrate legacy systems. So migrating the legacy systems is not an easy thing. Forklifting and shifting workload to the cloud is actually quite complex, trying to make sure that you have the same performance characteristics and make sure it operates the same as if it was in your on-prem environment. There's a huge performance demand, especially when moving from legacy platforms. Now, you have a server, there's a virtualization layer that you usually have on top of the cloud, and so there is a slight performance degradation in terms of how the application will operate, and helping governments size up how they deploy these applications in the cloud, these services in the cloud, is quite important. And we mitigate that with some of the offerings we have in Vault Systems. Now, another challenge is there are sensitive data, public sensitive information that we house for the Australian government. And in 2 classifications I mentioned earlier, the unclassified DLM range is more for the less sensitive, less critical information, but still sensitive to the Australian government. And then protected range is actually with identifiable information. This is health records, this is social information, some of your historical data, some records. So this information is quite sensitive if it gets leaked out to the public. And so there are steps involved in making sure that the cloud is secured in a way that complies with some of the directions from the Australian government. There's a governing body called the Australian Signals Directorate, and what they do is they publish this document called the ISM, Information Security Manual, and what that does, it describes 1,088 plus controls which a cloud provider or a service provider has to meet to be able to house this sensitive information. So how do we meet these challenges? These are quite big challenges, and a lot of service providers today, they go through a lengthy process to qualify people to move and shift workloads in the cloud. The problem is the government must move to the cloud. That's the policy. They have to adopt new technologies, and some of them are just not ready to refactor their applications to use containerization or any of the automation that you normally would use in the cloud. And so we developed this cloud adoption model, this maturity model, and it steps through the different progressive phases that a government entity would go through to be able to move their workloads into the cloud. The first phase is lift and shift. That's basically, let's take the virtualization layer that you have internally, let's V2V it into the cloud using some tools, and it operates exactly the same. You don't get the benefits of automation. The cost involved in that is pretty similar or even more expensive, but it's a move in the right direction. The next phase is how they optimize. So this is shutting down workloads they don't need. This is consolidating workloads. This is leveraging the performance they have in the cloud to scale and get into that next phase, which is orchestration and automation. So the orchestration and automation phase actually now yields a lot more cost savings, a lot more efficiencies. And that's where you use tools like Terraform or schedulers that basically spin up workload, shut down workload on demand. So a good example of this is a government website that houses a lot of integration steps between your tax filing and your medical information. And what it does is if you have a lot of concurrent connections, it would spin up more workloads, more workers in the front end. And as the tax season dies, it actually reduces the workers. And so normally what happens there is they rent out these huge cages inside a data center, and they would spend the next 3 months cabling and getting that all together to be able to handle the workload for the tax season. And that sits there for about 6 months, and then it gets torn down again, and then it's another cost to bring in the consultants and the people to be able to do that and rack and stack it again. And so that orchestration and automation step helps phenomenal adoption into cloud and also reduces dramatic cost. Cloud native is true nirvana in terms of moving your workload. That's where you actually get your devs together. Let's refactor the application. Let's use containerization. Let's use some of the new things that are available in the cloud, object storage, and things that are true cloud native, which make it more portable, highly available, and improves the performance of the application. So I talked a little bit about true hybrid cloud earlier. The Australian government actually has this initiative through the Department of Finance, and they created this network called the ICON network. And what this ICON network does is it actually creates a fiber link from any department to the data center. And so you can order ICON link, it is your fiber, it's your media, you put whatever transceivers you want on each end, and you have a high fidelity, low latency link directly to a data center. Because Vault Systems operates only in Australia and is sovereign, we're able to leverage that kind of relationship with the Australian government. So what does that mean? That essentially what it means is if I spin up a workload in the cloud and it's available online, I can reach it. I can literally ping from my desktop to the cloud a workload in a sub-millisecond latency. So this improves things like VDI, which is great. I mean, your experience will be phenomenal with this. It allows you to now host a true hybrid model, which means that you can have your database on one side, your applications on the other, or however you want. It essentially extends your data center. So this whole idea of having this high fidelity link allows you to actually have a true hybrid cloud offering. Some of this information on the slide, you'll see that we use a L2 termination. Vault operates a layer 3 fabric internally. And what I'll do is I'll get into that a little bit later on. This gets into more Mellanox and sort of the Linux OS with Cumulus a little bit later on. Hyperconverged. So to meet the demands of a lot of the performance of legacy applications, we had to sort of create a truly scalable model to be able to facilitate big applications. And what we found was we can create a hyperconverged model, which allows you to have storage local on the disk with the compute and the network. So this model allows us A, to scale rapidly, and B, have low latency connectivity to your storage. So our tier 1 storage is actually on the same device, or the same server as our compute. And so having that tier 1 storage and also another tier storage, which is our tier 2, which is a traditional Ceph cluster just in a rack, allows you to have A, fault tolerance, and B, high performance on the tier 1 space. 100G network fabric. So because we're leveraging Mellanox and Cumulus networks, we are able to decouple a lot of the reliance on specific vendors to offer both the OS layer and also the hardware layer on our network. And Mellanox offers 100G fabric, so we use that, and that's directly to our nodes. So the entire network inside of Vault Systems, with the exception of the management network, which is for out-of-band management, is truly 100G. OpenStack. So a lot of the complexities around meeting these controls that the Australian government sets out has to do with some intricacies on how we handle data, how we sanitize data, where data lives, and where data is actually kept. So because we're using an open platform, we actually are able to adapt a lot of the controls to meet all the control, all the regulations and metrics that are needed to be able to comply with the Australian Signals Directorate. And OpenStack is a great platform, and we've had a lot of competitors who've come to the market, try to meet these controls, and it's just very difficult when you're relying on a vendor to say, how do we do disk sanitization on a storage tier, or how is encryption handled? It's a black box. You don't really know. You'd have to talk to some engineers inside the vendor, and so on and so forth. So because we're truly transparent, we actually show the source code in terms of how our cloud operates. It's upstream. We use upstream OpenStack, so anyone can look at the code and see how this data is handled. Test and automation to handle security compliance and control. So we leverage a lot of test and automation to be able to make sure that all the rules and all the changes in our infrastructure is done correctly. So what that means is we have a gated commit process. So we have our engineers, and if they want to make a change to our network fabric, we don't actually log into a switch and say, enable and then make a switch configuration change on a port. What we do is we actually have a test and dev environment. There's a test phase which they commit a change based on the commands they would normally use. It goes through a verification process. That gets into a few more gates until it actually gets committed into the mainline master, which then affects production. And so what this allows us to do is it allows us to onboard engineers at a high rate. So if an engineer is green, they don't really know what they're doing. They're sort of like just getting used to the company culture, getting used to the tools that we use. They can commit a change. Our test parameters are actually quite exact that it will simulate what the effects are in a test dev environment. And if it passes the test, it will actually go to the next authority to be able to peer review and commit it to the next stage. So it allows people to be a little more flexible in the company, to be able to commit a change, see what the effects are, and basically allow us to have a phenomenal uptime. So I said again, Cumulus and Mellanox is sort of the key aspect of our network. And the reason why we chose these two vendors is because we were able to decouple the OS portion of the network switch and the hardware-based network switch. Providing this level of choice is actually quite great, because if I wanted to get to the next, let's say I wanted a new ASIC from another vendor, I can go ahead and swap it out. The OS level stays the same, and I just get new functionality based on the hardware I put underneath the OS. Same thing with the OS. I can, if I'm using a more decoupled hardware provisioning system, I can actually put another OS. Let's say it's now Cumulus down the road. Maybe it's another vendor. We want to try them. So having that choice provides us with a lot of flexibility and a lot of power to be able to make sure that we run our systems at the highest possible performance level. Extreme performance with the Spectrum switches. You guys should definitely visit the booth with Mellanox. They have really great technology. There's a lot of offloading with VXLAN, and a lot of the capabilities that we have on our fabric is actually, we've realized that there's a lot of efficiencies with some of their switches. So definitely give them a shout and see what they have to offer. But again, going back to the throughput that we have available in our cloud, it's been quite great moving from a legacy vendor into these new decoupled systems. So Cumulus allows us to use a Debian-based OS. So you essentially get a server which has a lot of ports. That's essentially what you get with the Cumulus OS. And that makes our developers really, really happy, because you don't have to learn another operating system. You don't need to learn these commands. I can go IF up and IF down on a switch port, which, if you were using another vendor, that command just wouldn't work. We've gone to the point where in our test and dev environment, we had a little bit of fun and started putting some other applications on the switch. So you can run anything you can run in Debian on the switch. You can put a Minecraft server there if you want. So there's a lot of flexibility there. But again, that allows us to put some customizations on our switch. So we can write middleware that's written in Python, or we can write something that's written in other languages, and sort of allow us to massage the switch and give some additional functionality if we wish. Full automation for bare metal provisioning. So in our company, we use a lot of Ansible. And so our entire cloud is provisioned through Ansible OpenStack, and our switch fabric and our configurations done in Ansible too. Because we use layer 3 internally, it doesn't matter which port you actually plug a server in, so which makes it really, really easy for our hardware, our rack and stack guys to get our cloud up and running. As hardware comes in the door, it's about a one-day turnaround to rack and stack and get it online to be able to provision through our bare metal system. So our tool chain with our DevOps team actually has come closer to the infrastructure because of this. Since we have a single tool, or we have a defined tool chain, we're able to see the efficiencies in how we actually use some of the DevOps tools. You know, the artifacts that we provide with some of the configurations, the gated commit process like I mentioned earlier, and so on and so forth. So having that flexibility, having that sort of ecosystem actually works in our company culture. Economies of scale. So the scale-up model with Mellanox and Cumulus is actually quite great. As I mentioned earlier, we use BGP internally. It's all layer 3. And so as we grow our cloud, we just grow the leaf switches and more of the spine switches as we need. And so that resulted in an extremely fast provisioning process. We didn't have to worry about a lot of the complexities around cabling, so we didn't need to hire experts to cable our racks, or cable our switches. And so, you know, you get a guy, he racks it up, screws in the cable, screws in the servers, plugs into whatever port he needs for the 100G ports or the QSFP 32 or 25 ports, and they're good to go. Robust networking. So because we're doing a layer 3 internally, a port dies, we don't have any problems. We're not using STP or anything. We're using all BGP. So it's a very, very familiar technology. It works for the internet. It works for us. So I'm going to show you a little bit of a high-level design that we've created in Vault. As you can see here, we have a layer 3 BGP fabric, and we have our compute host on the very, very bottom. There is an actual service that runs on top of our host called FRR, and this does the routing to be able to traverse layer 2 packets through our layer 3 fabric. And again, when I talked about Icon and that dedicated connection, if you look at the top left, you'll see that there's a government agency who directly connects to us using a fiber link. This is normally a 10G, 40G, or 100G network, or a 100G link, and it goes into security switches. And what these security switches do is they actually have a service that terminates the layer 2 segment and translates that into VXLAN, and it goes right to the host. So in essence, our layer 3 fabric just becomes a transit of our entire network. And then you get your public network, public internet through a secure internet gateway, which is how we provide services to the instances inside the cloud. All right, so after all of that, what we've found is we've been able to create this truly transparent model with the Australian government. We were the only service provider, only cloud provider to provide 100% ISM control compliance. A lot of the other competitors have to have some mitigation steps. And what that means is if you were to use another provider, you would have to sign off on the risk to use some of their systems. And they have to disclose that, and it's a process to be able to get government agencies to sign off on risk because they're more risk averse than you might think. Cumulus Network and Mellanox delivers true hybrid cloud, again with this Icon layer 2 fiber and our layer 2 stretch network from an agency to our data center. It provides that high fidelity link and allows them to actually use workloads in the cloud to their advantage very seamlessly. Hyperconverged design delivers unparalleled compute performance. So the compute performance has been measured to be extremely high performance. It has been used on a lot of database applications. We've seen improvements in some of the ML workloads and other workloads that really push the limits on latency on the disk. Reduce risk with open standards. So what we tell government is that because we're using an open standard, you can always take the upstream code, deploy your own cloud, and bring your workload back. That layer 2 stretch allows them to do that exact thing. Because they have that link, because they have open standards, there's no lock-in. It's full true portability. So we leverage our build pipeline for network configurations. So we've reduced our issue footprints, our actual configuration mishaps, quite dramatically since we've gone through this pipeline phase. And so when we started, we actually went and used a VMware technology. And we were using some of the tools, and we found that there was a lot of disconnect with how we develop code and how we deploy in production. Now that we have OpenStack and we're using Cumulus and Mellanox, it's been phenomenal. So that build test phase can be replicated in a virtual environment. Tests can be run, the results can be gathered, and it can get to the next step. Sharing OS security hardening and automation for government. Because we believe in being truly transparent, we show government, we actually publish on our GitHub how we harden every image, how we go through our Puppet automation to be able to meet all the controls on the OS level. And so that gives a little bit more, I guess, security from a government point of view, where they can use that same code in our GitHub, open a GitHub account, and see how we change things and how that's applied to the cloud. So the next thing is looking forward. We're looking at K8 CNI visibility with NetQ, and so we're seeing more and more people adopt Kubernetes in our environment. Being able to see some of that and report on some of the performance metrics on some of these clusters is going to be quite important. We're looking at RDMA, NVMe over Fabric. So, like I said, we have the hyperconverged model. There is also a model where we want to provide even more offload from the CPU and go directly to a host card to be able to provide higher, better storage performance. And that's it. So thank you for your time, and I can open it up to some questions.